So what we're showing here is the Snapdragon 800, which is the latest in the Snapdragon series of chips. This is being shown in our reference design here. It's not commercially available yet, but it'll be commercially available later this year. We have 3 demos that we're showing to highlight the GPU and CPU capabilities of the Snapdragon 800 for 3D graphics and gaming. So we've got 2 games from Gameloft. So we have Dark Knight Rises and Asphalt 7 from Gameloft. These games were specifically enhanced for the 800 series with additional visual effects, such as you can see the rain sort of cascading off of Batman's armor and some other similar effects like that. The demo in the center here and also on the upper monitor, this is Snapdragon Fortress Fire. This is a technology demo that was developed by our internal team to highlight some of the visual effects that are possible with the new Snapdragon 800 series. So as you can see, all of the scene, the cloth is being simulated in real time, and I can interact with that cloth. Showing you some of the effects in the scene, we have real-time reflection and refraction, in addition to real-time shadowing. Some of the other visual effects you can see is I'll bring the dragon down here. Everything in the scene is being dynamically lit by multiple light sources, and it's rendering a huge amount of polygons, as you'll see shortly here when this switches into wireframe. These sorts of effects previously may have been possible on mobile, individually, dynamic shadows, reflection, refraction, but to use them all together, rendering at this resolution at 30 frames a second, really I think showcases the kind of console quality graphics that we expect the Snapdragon 800 to bring. One of the other things that I can show here is highlighting more about the CPU. So I'll bring up this bar graph here. So this graph shows the multiple cores that are in use. Of course, doing things like real-time cloth simulation are computationally expensive operations, and you can see that we're distributing that workload across all the 4 cores of the CPU, which are also scaling their frequencies asynchronously. That's something that's unique to our hardware, and that the CPUs can scale up or down their frequency based on the workload on an individual core basis. In addition to that, if I pause this scene right now, basically turning off all the animation, turning off the simulation, you can see that the system basically disables 2 of the cores. It doesn't need them to compute the workload that's going on in the scene. And immediately, as soon as I unpause this, those cores are brought back online to meet the demand of the application.